welcome back to 11.4. The next thing that we're going to look at is equations that are quadratic in form. So these are equations that are not quadratic, but they have a very similar form and we can use the same techniques to solve them. So the first one I have in example 4 is 9x to the fourth minus 37x squared plus 4 equals 0. And you'll notice this is not quadratic. We have an x to the fourth power as our highest exponent. This is a quartic problem. So not quadratic, but it is in form. So what I mean by the quadratic in form, especially I think it helps to look at that middle term. We have x squareds instead of x's. X to the fourth is x squared squared. So if it helps you a little bit, that middle term is x squared. I'm just going to say that y equals x squared so that you guys can see the quadratic in it. So x to the fourth is x squared squared. So I can just say that this is the same thing as y squared. So I'm going to have a 9y squared. And then I'm going to say that y is x squared. So I'm going to have a 37y plus 4 equals 0. And I think that substitution, you can see a little more clearly how it is a quadratic in form if we use that substitution to say that y is x squared. Okay? So then from here we can use kind of our normal solving techniques. You can factor if you'd like to. It actually factors pretty nice. You know, to get the 9y squared, 9y times y is 9y squared. To get the 4, 4 times 1 is 4. We will use a negative 4 and a negative 1 so that we get a negative in the middle. And then negative 36 plus negative 1 is the negative 37. So that's the right combination for it. Hopefully you guys are good at factoring by now. If you're not, that is chapter 5 if you need to go back, okay? So anyway, from here we'd set each factor equal to 0. I'd have 9y minus 1 equals 0. I'd have y minus 4 equals 0. And I'd solve my little equations. I'd add 1 and divide by 9, say y is 1/9. I'd add 4 to both sides, say y is 4. Now we solve for y, but of course the original equation doesn't even have y's in it, it has x's in it. We need to actually solve for x. So y is the same thing as x squared, that's what we use for all of that substitution. So I'm going to say that x squared equals 1/9 and x squared equals 4, like that, so that I can actually solve for the x's and kind of back substitute, okay? So to solve for x from here, I just take the plus or minus square root. So if I take the square root of 1/9, I'm going to get positive 1/3 or negative 1/3. If I take the square root of 4, and again you're doing the positive and negative version, so we'd get 2 or we'd get negative 2. So we actually get 4 answers, which is kind of expected. When you start out with an x to the fourth, that highest exponent tells you how many answers you can get. Sometimes you'll get repeated answers, and so then it'll have basically less in your answer list. Because you don't list out the repetitions. But with these, we did have 4 unique answers. Let's do another one. Example 5. I think we'll just move to a new sheet here. I've got 4x to the 2/3 power equals 3x to the 1/3 power plus 1. And again, you'll notice this is not a quadratic. It's not an x squared. It's x to the 2/3. So basically, instead of x squareds, we have x to the 2/3. Instead of x's, we have x to the 1/3. But x to the 1/3 squared. Remember that squaring an exponent, basically you multiply those together. 1/3 times 2 is 2/3. So if you notice your exponents, one is twice as much as the other, then you actually are quadratic in form. So 1/3 times 2 is 2/3. That's how I know it's in that quadratic format, even though it's not actually a quadratic. Okay? Let's go ahead and get this in standard form. Let's get everything on the same side. 4x to the 2/3 minus 3x to the 1/3 minus 1 equals 0. Just subtracting these from both sides so that everything is on one side. Okay? And if it helps you to do that substitution, you're welcome to. You know, we can say that y equals that middle, that x to the 1/3, and use that substitution. So we have a 4y squared minus 3y minus 1. So you can use a substitution if you want to. If this confuses you, you're welcome to leave it out, okay? The other option, if you don't want to use that substitution, is, you can just say it is what it is. This is 4 times, x to the 1/3 squared, if you want to do it like that. Minus 3 times x to the 1/3 minus 1 equals 0. You can always just leave it as it is if you're comfortable with it as it is, okay? But I think the substitution helps sometimes, so if you want to keep going with that, we can. This is another one that actually factors pretty nicely. It just happens to. So 4y times y is 4y squared. -1 times +1 is -1, and then just checking the outer, that's -4y. The inner, that's 1y, and -4y plus 1y is -3y, just like we're looking for. So this one did factor nicely. If you want to use the quadratic formula or completing the square, you're welcome to do that, okay? You'll just have like y equals instead of x equals, and again, don't forget that substitution at the end. So we'll set both of our equations equal to 0. 4y plus 1 equals 0. Y minus 1 equals 0. So to solve the first one, I'd subtract 1 and divide by 4. So y is -1/4. The second equation, I would just add 1 to both sides. Okay, and yet again, we're not solving for y, we're solving for x. Now is the time when I kind of substitute back. Y is x to the 1/3. So where I have a y here, I'm just substituting it back in. The x to the 1/3 power equals -1/4. And same thing here, with the y is equal to x to the 1/3. We did that earlier, okay? And now you're like, oh, how do I get rid of that 1/3 power? We cube it. So the 1/3 power, if you guys need a quick refresher, that's the same thing as the cube root of x, okay? So the opposite of cube rooting is raising something to the 3rd power. So that's how we're going to get rid of that 1/3 power. And if it helps, 1 times 3 is 3, and 3 divided by 3 is 1. We're just going to get a regular x after that, okay? On the other side, raising that to the 3rd power, that would be -1/4 times -1/4 times -1/4. So -1 times -1 times -1 is -1. 4 times 4 times 4 is 64. So x would be -64. The other one, we're going to do the exact same thing. We're going to raise both sides to the 3rd power. These undo each other. We'll have x to the 1st. And then 1 to the 3rd. 1 times 1 times 1 is 1. So there's our 2 answers for this problem. Now it's your turn. You all get to try one and show me how much you've learned.